Hey, hi everybody. I'm so glad to present your research work here. In this paper, we present a high-order refining mechanism for improving end-to-end semantic role labeling for Chinese data. For the record, the SRL task has a shallow semantic parsing aims to recognize the predicate argument structure, such as who did what to whom, where, and when, just like the example as shown below. Here we focus on the end-to-end SRL. We perform the predicate disambiguity and arguments role labeling in one shot, like via one unified model, and we just model the task as a predicate arguments role triplets prediction. The end-to-end joint architecture can greatly alleviate the error propagation problem and thus helping to achieve better task performance. Currently, the end-to-end SRL methods largely are graph-based neural models. They enumerate all possible predicates and the arguments exhaustively. However, these first-order models that only consider one predicate arguments pair at a time can be limited to short-term features and local decisions, thus being subjective to long-range dependency issue. This makes it imperative to capture the global interactions between multiple predicates and arguments. So, in this paper, based on the graph-based neural model, we propose to further learn the high-order interactions between all predicate arguments pairs by performing iterative refining for the underlying token representations. Our high-order refining SRL model take the baseline first-order graph model as backbone. We can inform each predicate argument pair with the information of the other rest of the pairs from the global point of view. We reach this by obtaining the high order feature representation like this. Uh, we just use a attention mechanism to achieve this. And then we refine the underlying token representation like the like the arrow indicates. Mm. We refine the online token representation with the refined one here, which carries high order interactive features. Yeah. So during training, we minimize the negative likelihood of the golden triplet structure. We measure the triplet structure via some scorers, and this follows the baseline end-to-end graph-based neural model. In the experiments, we first examined the joint SR performances on the corner 6 Chinese data, and we find that the joint detection for predicate arguments can be more beneficial than pipeline detection of SRL, and high-order end-to-end model outperforms all these baselines on both true subtasks. And besides, on the universal proposition bank Chinese data, overall, similar trends are kept as that on corner 6. Our high-order model still performs the best, and yielding like 67.6% F1 score, arguments role labeling, and this verifies its prominent capability for the SRL. We next examine the performance on the varying refining iterations, as shown in the figure, compared with the first-order baseline model. Our high-order model can achieve better performances for both two subtasks. We find that our model can reach the peak for predicate detection with total two iterations of refinement. Well, the best iteration number is 6 for arguments labeling. This the figure at the right side shows the performances of the argument's recognition by different surface distance between predicates and the arguments. The overall result decreases when arguments are farther away from the predicates. Nevertheless, our older model can beat against such drop significantly, especially when the distance grows larger, like distance more than 7. The winning score by our model even becomes more notable. Alright, done for the presentation. Thank you so much for your attention.